Greetings internet buddies, welcome to lesson 7 of our Golang for Absolute Beginners tutorial. Today we are going to continue making the game Unique Candlestick. To do this I'm going to need to tell you a bit about how the game works. So each player has cards with the numbers 1 to 13, ace to king. 3 of these cards in hand and the rest face down in their deck. They then take it in turns to place a card from their hand into the middle of the table face up so everyone can see. And the player with the highest unique card wins the point. Once every player has played a card, the player who played the highest unique number wins a point. Each player then draws a new card from their deck and play continues, starting with the player who won that trick until all the cards have run out. When all the cards have run out, the player with the highest unique number of tricks is declared the winner. Ace is normally low, but when you play a card in the middle, if there is exactly one king, ace is considered high as 14, where kings are 13, etc. 8 and 7 both reverse the winner, assuming that they're unique. If there's more than one of any card, it's basically discounted from that round, but they can be played. So if exactly 1 7 is played, the lowest card wins. If a 7 and 8 are played, the highest card wins. The only weird case is if, of course, you get 2 7s and 1 8, which you might think makes it... Actually, that does still make it lowest wins, because the 2 8s cancel each other out, and then the 7. But if you have 3 8s and 1 7, it still means lowest wins, because all the 8s cancel out. Today, the plan is to make the function that takes a list of numbers and responds with the winner according to the rules I've just given, or -1 in case of no wins, if everybody plays the same card, for example. First off, how did you do with last week's challenge? Last week I told you you had to create a function to make the new deck and put the result into a slice of slices. I left you to work out how to make a slice of slices, but let's give it a go, shall we? If you didn't manage to work it out, then I guess now's where you find out. So here we go. Actually, yeah, no, we'll do it here. Func make deck. This doesn't actually need any parameters, but it does return an array, a slice of int, right? And the next thing, well, actually it's going to be basically the same as this. We'll leave the seeding of random numbers to the main function. We'll just keep using the same random thing. Cards colon equals make. Yep, that's definitely needed. So this is all stuff that we did last week, and this was our shuffling. So if I copy all of that and put it into our make deck function instead, because we're going to make 4 decks, we're going to assume there are 4 players. There may actually be more than 4 players, but for now we're going to work with 4 players. This game actually works quite well if you've got 8 players. Random seed. Oh no, we've done the seed. So that's where we set the random numbers from the current time. And now we're going to have a for loop. Oh, this doesn't actually return anything yet. So we need to now do return cards. There you go. So this was our function that makes a slice of ints. But the challenge, of course, was to where do we put them? Well, we need an array or a slice of slices of ints, which is a little bit weird. But basically, you can make a slice of anything in Golang. You can make a slice of int, you can make a slice of bool, you can make a slice of strings, you can make a slice of any random type, or you can make a slice of slices. That's all it is. And so, all decks colon equals make a slice of slices of int. Currently that will be we'll set it to, well, we know how many people we're going to be, so it's 4, so that's not a problem. Just saves it reallocating memory every single time it replaces. We know we're going to fill it with 4 right now, then we should do that. So we made a slice of slices of ints. If that causes any confusion, it's kind of helpful to think that this is a slice. I'm going to get rid of these brackets because I think it's probably a syntax error, but it's kind of that. We get, this is our type that we're working with, a slice of ints, and we need more than one slice of ints. So there you go, we have a slice of slices of ints. That's how Go will see it. So then we're going to have our little for loop like usual, for, and we're going to fill up 0 to 4 splices. So for I colon equals 0, I is less than 4. So that will be 0 to 3. I plus plus. And again, I've been coding in JavaScript mostly in the last week, so I'm putting brackets there. You don't need them in Go. All dex at I. We've already assigned its size, so this should work. Did that work? It worked okay in the last one, yeah. All dex at I. If you want to go beyond the actual capacity of your thing, you're going to have to use a pen, but I've already set its size, so. Equals, and then the function is make dec, and that basically sets us up with 4 decs. I don't think printline all cards will work because it's an array of arrays, but let's give it a go. Like, it will work, it just won't print what I think we want it to. So I'm going to have to test that we've got the right thing. Go run candlestick.go, and let's see what we get. Oh, it did work. So we now have an array of arrays. So this array is the array inside this bigger array, which goes all the way down to here. So that's why you got the 2 squares, and then another array here with different numbers, all the numbers from 1 to 13. So I think we have achieved our random decs for everybody. So it's time to get on with today's, I guess, planning, which is to make our function. This is kind of the core function of the game, actually. This is the decide winner function. Or, no, it's not. I can't call it decide winner. I'm going to call it decide trick, because decide trick. Troc. I can't type today. Func decide trick. And this will take, I'm going to call it AR, short for array, and this will be an array of ints, but it's not a slice of ints. And this will return an int, which is the number of the player who won. So in theory, I'm going to make this capital because it actually might be useful for random things. Some other random might want to use this. Oh no, it's package main. Probably not worth it. Decide trick. So this function here, decide trick, takes a list of cards, one for each player, and decides who won according to candlestick rules. Okay. So the first thing we do, no card that is not unique can win. So kind of want to create an array where no card that's not unique is allowed through. This feels like the easiest way to do this. So I'm going to make a new array. Uniques. Colon equals make. Actually, we don't know how many cards we're going to get into this. I'm not going to bother assigning it. But it is an array of int, a slice of int. But we'll set its initial capacity size to 0, and we'll just append to it. So uniques is our bit that's going to track all the cards. If any card is not unique, it's not going to make it through into this array. So the next thing we need is to kind of go through our for loop and check how many it contains of each list. There are probably more efficient ways of doing this, but all I'm going to do is I'm going to loop through the list and for each element check that it's unique. So for I colon equals 0, I is less than length of the array, I plus plus, if AR, this is the question that we want to ask, and I'm probably going to have to rewrite it, but AR at I dot is unique. This is not actually correct code. I'm just trying to come up with a way of writing out what I want. If that is unique, then put it in uniques, right? So uniques colon equals append uniques and AR at I. It's expecting it. Colon expected found colon equals. Oh yeah. Okay. Again, the problem of JavaScript requires brackets there. Golang doesn't. In fact, Golang very specifically requires no brackets there. Now, is unique is the question that's going to be a challenge. To find out if it's unique, we're probably going to have to go through and we'll just loop it again. So for j colon equals 0, j is less than length AR j plus plus, and the usual way I do this is you set a solve variable. So is unique equals colon equals true, and in here if AR at I is equal to AR at j, then is unique becomes false. So if ever we find one that's the same, we set it to false. I don't know how much sense this will make to if you are an actual beginner. So let's give this a quick run through and see if we can see. Both these, I'm actually running through the array an extra time for every element of the array. So if this array has 100 elements, I'm going to touch all of the elements 1,000 times. Thankfully, it's likely to only have 4. So what we do is we're going to loop through. This just goes through each element in the array, but for each element in the array, we check each other element in the array. Ooh, haha! And there's a mistake that I made because, of course, it's going to come across. There will be a point where I is equal to j. So we need to do a quick check on that, and I does not equal j. Because if I is j, then you're guaranteed to get a point where they all become not unique because it's found itself. So here we run through the rest of the elements in the array and rub it out. Then we come down to here, and now this is unique is now a variable, not a bracketed thing. So, and it's just a local variable. So that makes sense to me. If so, At this point here, we now have a list of unique numbers in the array. I think we probably need to do some testing on this decide trick. So, welcome to testing. Yes, this is actually a good idea to introduce testing now, because this is a perfect place for a test. One of the nice things about functions is that they can do that. For now, we'll just return length of uniques. It's not the correct answer for this function, but welcome to testing. Yes, so we're going to create another file in the same directory. From Vim, I just do that as edit. And this file will be called candlestick. Now here's the important bit, _test.go. If it's called _test in its name, the Golang compiler ignores it for normal running, but when you run go test, it actually checks it. So we're going to create what's called a test file, a test library. Oh, did I forget to tab edit? So I've just that's all right. So this is going to be in our same package, right? So package main, and in this we need a func called, and it tends to, I don't know for certain if it requires the word test, but it's helpful to have it anyway. Test, and it has to be a capital T because it can't, the test package can't find unexported functions. So test deletes, no, test uniques, and this takes, oh, and that's why I do need to do an import. We have to import a module called testing. Import testing. Actually, Golang testing is really nice. I've tried testing in other languages, and Golang, I find, wants me to write tests, and it feels good to write a test for a library function, or particularly the function that we just did. I tab edit candlestick.go. So this function, because it's a natural function that takes an input, returns an output, and it's fixed, it's very easy to test a function like that. So, like, what the output will always be the same as long as the input's the same. So test uniques, we can come up with an array of arrays, or we can just let's quickly do it the lazy way for now. There are better ways, but for now I'm just trying to introduce you to what you are doing. Test uniques. Now this will take a T, which is a pointer. That's T is just the name, so you can call it what you like, from testing dot, I can spell testing dot T. So the type that T is testing dot T. It's a type that's defined in the testing library, which allows you to fail the test and pass the test and everything like that that testing needs. So the first thing we're going to do is we're going to call that candlestick.go test function, not test function, it's called decide trick. So a colon equals decide trick 3 comma, oh, putting it in an array of int. So we're making a new array of a new slice of ints, into which the numbers we're going to put are 3, 6, 5, 6, 4, 5. So the unique numbers are 3 and 4. So in theory, the length of A, or the answer A, should be 2. So if if a does not equal 2, t dot fail. And now Golang, just write go test. If you don't even need to write anything else if you're in the right folder, and it passed. That's good. Let's just check that it is testing correctly, because it was happy to pass that test. Oh, let's do it verbose actually. -v to make it verbose so you can actually see it. It's run test uniques and it's passed text uniques. What if we had written does not equal 3? What would happen there? Hopefully we get a fail. That means our test is working. We expected the answer of 2 and it's returned 3 and we've made it fail the test, which it should actually pass. So we can actually test that this gets the right answer in more cases, but that is your first introduction to testing library in the first place. So you just write a function called test something with a capital T and give it take a T from testing, and that's where you're going to write your responses. So this probably works. You could do with writing some more thorough tests. So now we have a list of unique things. We now need to find out if there is a king. So that the question is ace high, right? So we have a variable called var ace high colon equals false. But if this contains a king, which is number 13, then ace high needs to be true. Remember, if there were 2 kings, this wouldn't include them. So I'm pretty sure there's a straightforward slice contains function. So I'm just going to have a quick peek for it. Golang slice contains. Go contains method for slice. Is there anything similar to a slice.contains object? This is actually an interesting idea. We might use a map. We could either write our own function for contains, or instead we can use a map. I think I'm going to write a quick contains function, but at some point we're going to introduce maps, and maps are really cool and we use them. So let's go back here and have we already used contains? Oh yeah. Let's write a contains function, and then we can actually use that in the isUnique thing. Because if we make contains return an int, then we can always check for more than one. Func contains and this will be n. No, it's an array. Array, which is a slice of ints, and it's going to return an int, which is the number it contains. For I colon equals 0, I is less than length of AR, I plus plus, res equal colon equals 0 if we're checking if it contains something, right? So we've got another int. I'll call it C for check, and that's an int. if C equals AR at I res plus plus. Plus plus means add 1 to it, just like in the I++, I guess. And then return res. Now what's he complaining about? Line 12. Is this line 12? Yeah, this is line 12. Expected operand found if. So what? Oh, semicolon missing. Semicolon there. So now we have a contains function. We can set this much more tidily. A colon equals contains our uniques 13, that's the value of a king, is greater than 0. So if the answer is 0, then this ace high will become false, because this result won't be bigger than 0. If it is bigger than 0, ace high will become true. Reverse. The other thing we do is we've got to have a thing for, do we reverse the deck? Reverse colon equals I'm going to set it to true and do it the slow way around, okay? If there is a single line way of coding this, but if contains uniques A7, then then reverse equals not reverse. I can probably put that not there. So that's just, yeah, that just flips it. So if it was true, then it becomes false. If it's false, it becomes true. We can do the same one if contains 8. Contains uniques 8. Then we need to do the same reverse. Reverse does not equal reverse. Well, no, reverse becomes not reverse. No, that's I don't know if that works. I'm going to put the not on that side because I know that makes sense. Not switches it. So if it was true, it becomes false. If it was false, it becomes true. So if it contains a 7, exactly 1 7, then it will reverse. If it contains an 8, then it will reverse. Again, that's pretty tidy. And now, the is unique can be written as a single function too, because we've written that contains method that I couldn't be bothered to write before. Is unique becomes, undo that. Contains AR at and it's supposed to be containing AR at I, and the question is if that is, it's unique if that is less than or equal to 1. Because if it's got one entry, then it's unique if it contains this 1. Actually, it's only unique if it's exactly 1, right? The less than shouldn't ever happen. And that just makes that a little bit tidier over here. So we now know whether we're reversing or whether we're winning. So the next question is, which one is highest or which one is lowest? And how do we respond to an ace? So we need a function that says, does this card beat this card? And it takes these two parameters. I think I'm going to make a new function just because it just makes my life a little bit tidier. Func beats. And this is C1 int, C2 int. Then we have ace high and reverse, which are bool. And this returns bool, which is, does C1 beat C2? Returns true if C1 beats C2. That's fairly clear for comments, don't you think? And then so the first thing we need to do is we'll set 1s to 14. So if ace high if C1 equals 1, C1 equals 14. If C2 equals 1, C2 equals 14. So far, so good. Now the question is reverse. If reverse, now they should be unique actually, so we should be able to simply say return C2. Hang on. Returns true if C1 beats C2. So if it's reversed, we return true if C2 beats C1. And if it's otherwise, return C1 is bigger than C2. So that's our beats function completed. And then back to our, it's not in our main function, it's in our, this function, decide trick function. We now need to have a winner, right? We have a winning card, so we'll make that the first card, and then we'll run through uniques, and if there's one that beats it, it will replace it as the winner. Winning card equals cards at, oh, it's unique at 0. Unique 0. Now, interesting problem. If unique, oh, we can put this up here actually. I didn't yet say -1 for a draw, but here's the place where -1 for a draw applies. -1 for a draw. And we don't know how long unique is, but we can check if if length of uniques is less than 1, that is, there's nothing in it, we can just set equals 0. Put the brackets in the right place, equals 0, then return -1. That way we know all the way down here that uniques contains at least 1 entry, so this will be fine. For I colon equals, I think colon equals still works because it should belong in the block. -1. No, equals 1. I is less than length of uniques. And I plus plus. Now, why did I start I equals 1? I'll give you a second to think about that, but because normally I start I at 0, don't I? So the answer is, of course, that I've already made the winning card the 0th card of the array. So I don't need to check that one against itself. So I'm going to check all future cards and if they beat it. So if beats, and that's uniques at I. The uniques at I beats the currently winning card. And it was ace high first, and then reverse as the 2 options here. In this case, winning card now becomes uniques and I. And then the very last thing we do is we return winning card. So now we can go back to our test method and see, oh, not that one, nope, that one. Now we wouldn't expect the result 2 anymore, now we'd expect the result 4, I think. So, because in theory 4 is our highest card, so let's run a test. It failed. It didn't even compile, that's why it failed. Candlestick Go 55. Non-bool contains unique values 7. Oh, yeah, contains. It's greater than 0. I made it return a number so that we could lazily do a couple of other things, but that should fix that. So this returns a number, and this operator here takes 2 numbers or ints and then returns a Boolean result. So if this returns the number 1, then it returns true. If this returns a 0, if this bit returns the 0, then it's not bigger than 0. This operator returns false. So we run the test now. It still failed. Line 63. And this needs an S. It failed the test though. That's not ideal. I was hoping that it would pass that test. So there are 2 6s, 2 5s. Let's see what result it actually returns. So thumped.println a. It's not, it's printf I want to do. A equals percent %s, no, percent %d, new line, and A. Obviously we haven't included testing, so let's do that. We haven't included thumped. A equals 3. So it got the right length of unique though. We got that far before. 6 and 5 shouldn't have reversed it. Maybe I got the reverse wrong on the beats. Okay. Oh, of course I did. Reverse should be false. It starts false and it only changes. There we go. Try again. Passed. Good. So let's make a few more tests and make sure this is working correctly. So what I'm going to do to make more tests is I'm going to try and create a test table. Table-driven testing is a good idea in general. You get to come up with a load of things where it's correct and wrong, and so let's make that table. And the table will take an array. An array of ints, an array, and an expected result. I think it probably needs to be a struct. So type. Oh, I haven't talked about struct yet, have I? Never mind. Struct type test table struct. So a struct is basically a way of organizing things so that you can access parts of it by name. So this is going to have question, and that will be a slice of ints, and it's going to have expected, which will be an int. And the table we're going to have in here, table equals, and this will be a test table, new slicey thing. So, and in here I'm going to put each of the elements, which will be, this one's an array of, oh, yeah, so this will be a test table, which I'm going to create now with an array of ints, and we'll do 3, 6, 5, 6, 4, 5. And our expected result will be we decided the expected result was 4. Put a comma on the end of that. Yank this. So we can make a bunch of these tables here. So this is kind of what our table looks like. It holds the inputs, the outputs. So let's change this so that we have, instead of that 6, we now have a 7. And now I believe our expected result would be 7 means lowest wins, 3 is the winner. Battery's running low, better switch it on. Power. Make another table here where we have get rid of this guy, replace it with a king. Oh, king is not king, is it? 13. And we'll have this guy as 1. So in theory, the 1 should win this. So I'm going to put R on 1. But I'm going to put a 1 in here. And this time I'm going to put 2 kings in here. And this time the winner should be, there's no 7s, this time I think the winner should be 6. So now we can do our test in a loop for, as usual, I colon equals 0. I is less than length of tab I plus plus. R colon equals decide, not capital D, decide trick int. No. We just take tab at I dot question. So the table has these 2 parts you can access by name with a dot after them. Then if R does not equal tab at I dot expected, then we've got a problem. It's not achieved the expected result. Obviously we need to fail the test, t dot fail. And then we can do a funct dot printf. And this time we can put some nice tidy information here actually. We can put test colon percent, I think it's percent %q for arrays. No, try. I'm not completely sure what to put there. It's not hex. I'm just going to put a string and I hope that it gets it what I want. And then it's %i d expected %d got %d new line close quote, and then the results are tab I dot question tab I dot expected and R. close bracket. So now it's going to tell us which tricks failed the test. If any of them fail the test, we should get to hear about it. So, in theory, when I run this, it passed. So, that's good. That means it's actually working. But I didn't get to test out all of my wonderful testing code here. So let's just say we put the wrong answer here, and we think we're expecting 5 to win this. It's failed, so it's got near enough readable results. The test of 13, 6, 5, 1, 4, and 5. We expected a 5, we got a 1. Actually, we expected a 1 because this was correct. So, we now have a test that works of our function that works out who won the game in a really easily testable format. So now I need to work out what your challenge is. I want you to write another test method inside the candlestick go.test that tests this, that tests our contains function. Okay? Actually, you can test every function we've got. We've got a contains function. You can test the beats function directly. So yeah, write test methods for the contains and the beats functions included here. You will need to be package main for this to work because these are lowercase functions. If these weren't lowercase functions, you could get away with not. But so contains and beats. If you can write test functions for these to make sure they give the right result. So beats returns the correct result for which card wins if ace is high or reverse, and contains for if it is giving the right number. You can also do a test function for bonus work on make deck and see if that is giving you an array 13 long and all of the numbers unique. You can even use contains to check that they're all unique. So that's your challenge. Just get the test working and run the tests and see the results of all of the tests. And that's where I'll leave it today. Thank you very much. See you soon.